Alright, let's see how long it takes me to do CS50's problem set. Okay. Write a program to modify the volume of an audio file where input.wav is the name of the original audio file and output.wav is the name of the audio file with volume that's been scaled by the given factor. Example given 2.0. WAV files are a common file format for representing audio. WAV files store audio as a sequence of samples, numbers that represent the value of some audio signal at a particular point in time. WAV files begin with a 44-byte header that contains information about the file itself, including the size of the file, the number of samples per second, and the size of each sample. After the header, the WAV file contains a sequence of samples, each a single 2-byte or 16-bit integer representing the audio signal at a particular point in time. So we want to scale all of those up. Scaling each sample value by a given factor has the effect of changing the volume of the audio. Multiplying each sample value by 2.0, for example, will have the effect of doubling the volume of the original audio. Multiplying each sample by 0.5, meanwhile, will have the effect of cutting the volume in half. Okay. So far, we've seen a number of different types in C, including integers, bools, chars, doubles, floats, longs. Inside a header file called standard int.h are the declarations of a number of other types that allow us to very precisely define the size and bits and signed or unsigned of an integer. Two types in particular will be useful to us in this lab. uint8_t is a type that stores an 8-bit unsigned non-negative integer. We can treat each byte of a WAV file's header as uint8_t value. int16_t is a type that stores 16-bit signed positive or negative integer. We can treat each sample of audio in a WAV file as int16_t value. Okay, so let's open up VS Code. Get connected. Right, we will cd into volume. I've already got that going. Okay. Complete the implementation of volume.c such as that it changes the volume of a sound file by given factor. The program accepts 3 command line arguments. Input represents the name of the original audio file, output represents the name of the new audio file that should be generated, and factor is the amount of which the volume of the original file should be scaled. Your program should read the header from the input file and write the header to the output file. Recall that this header is exactly 44 bytes long. Note that volume.c already defines a variable for you called header size equal to the number of bytes in the header. The program should then read the rest of the data from the WAV file, one 16-bit 2-byte sample at a time. Your program should simply multiply each sample by the factor and write the new sample to the output file. You may assume that the WAV file will use 16-bit signed values as samples. In practice, WAV files can have varying numbers of bits per sample, and we'll assume 16-bit samples for this lab. Your program, if it uses memory allocation, must not leak any memory, so we must free our memory as well if we decide to use that. Okay, which I'm guessing we are expected to since they say it. Okay, so let's take a look here. So standard integers, standard io.h, standard library, constant int header size is 44, int main rgc, argc character times argv. So we have the number of command line arguments, and then we have argv0 being our file that we want to modify, argv1 being the file that we want to write to, and then the third being the factor. So argv bracket 2 is going to be our output. Yep, right there. Okay, so if it doesn't have a file open, argv2 w output. Okay, so one determine scaling factor. That 1 is going to be our file open. Read, write. Do they do +1? Not 4. Put output factor. Okay. So float factor. A to F. What is that? Go to the manual pages. Or a string to a float. Okay. String to a double. Double A to float constant char times nptr. ATF does not detect errors. Return value is the converted value. So printf A to, this is CS. Okay. So we want to read the file. Let me get a pencil. Okay, so for memory, lab 4, to read the file of arg v brackets 0. Brackets 1. Because argv1 is first command. Okay. So I want to read the file of argv1. We then want to ignore copy the header from input file to output file, read samples from input file, and write updated data to output file, close files. Okay, so read the file. Then we want to copy that file over to a new file. And then unit you'll likely want to create an array of bytes to store the data from the WAV file header that you will read for them from the input file, and using the uint8_t type to represent a byte, you can create an array of n bytes for your header with syntax like uint8_t header brackets n semicolon. Replacing n with the number of bytes, you can then use header as an argument to read and write to read into or write from the header. You'll likely want to create a buffer in which to store audio samples that you read from the WAV file. Using the int16_t type to store an audio sample, you can create a buffer variable with syntax like int16_t buffer. You can then use the @buffer as an argument to read into or write from the buffer. Recall that the AND operator is used to get the address of the variable. Right. Remember that. You may find documentation for read and write helpful here. In particular, note that both functions accept the following arguments. A pointer to the location in memory to store data when reading from a file, or from which to write data when writing data to a file. Size, the number of bytes in an item of data. And memb, the numbers of items of data, each of size bytes to read or write. Stream, the file pointer to be read from or written to. Per its documentation, fread will return the number of items and data successfully read. You may find this useful to check for when you've reached the end of the file. Your program should behave per the examples below. You will listen to output WAV by control clicking an output WAV in the file browser, choosing download, and opening the file in the audio player on your computer. It should be twice as loud as input.wav. Given that command line argument, when listen to output WAV, you should be half as loud as input. Execute below to evaluate the correctness of your code. Using check 50. Be sure to compile and test it yourself as well. Execute the below to evaluate the style of code using style 50. Okay. It's a lot. Now we want to cd and a volume. Let's input.wav. Oh, I guess we could just okay, so they don't let you see any of this. Oh man. Alright. But this is the header thing after this. Okay. So, first thing we want to do, how do we want to do this? Guess I should probably watch the video.
In this lab, your task is going to be to write a program in C that changes the volume of an audio file. Specifically, in this lab, we're going to be working with WAV files, a standard file format for representing audio information. What is the structure of a WAV file? Well, like any file, these files consist of bytes. And in particular, in a WAV file, the first 44 bytes of that file are the header for that WAV file that contain information about that file that your computer or programs on your computer might need to know in order to read and understand and interpret that file. After the 44-byte header are 2-byte samples of audio. Many of these 2-byte samples of audio repeated back to back to back, where each of these 2-byte samples represents the value of some audio waveform at a particular point in time. So ultimately, your WAV file is going to consist of one 44-byte header, followed by many of those 2-byte samples. And the interesting thing about those 2-byte samples is that each one is really just a number. And if you want to change the volume of a sample, you're going to multiply that sample by a number. If I have an audio sample and I want to double the volume, for example, I would take each of the samples of audio in the audio file that I'm trying to modify and just multiply each of those sample values by 2. Likewise, if I'm trying to cut the volume in half for a particular audio file, then I'll take each of the 2-byte samples and I'll multiply each by 0.5, or 1/2, in order to cut the volume in half as well. Ultimately, the way your program is going to work is we're going to run our program as /volume followed by 3 command line arguments. The first command line argument is an input WAV file, some file that already exists representing the audio file that we're here going to try to modify. The next command line argument is the name of some output file, some new audio file that our program is going to generate that is going to have the modified volume. And finally, the last command line argument to this program is going to be a floating point number representing the factor by which to change the volume of the original audio file. In this case, for example, we're using a factor of 2.0 to mean we want to double the volume of the audio file. But if instead we had tried to use 0.5, for example, as the factor, then we would be cutting the volume of the audio file in half. So here's what you're going to need to do in this lab. In order to take the input file and then generate a new output file that's the same audio but just with the volume changed, you're going to want to start with the header of that WAV file, since the header, those first 44 bytes of the file, are the first thing you'll find inside the input WAV file. So you'll initially want to read the header from the input file, and then you'll want to write that exact same header to the output file. After the header, recall, comes each of those 2-byte samples, many 2-byte samples back to back in the file representing the audio waveform of the file itself. So you'll want to repeat. For each of those 2-byte samples, you'll want to first read the sample from the input file, likely into some sort of variable, and then you'll want to multiply that sample value by the volume factor. If you're trying to double the volume of the sample, then you'll double that value. If you're trying to triple it, you'll multiply it by 3. If you're trying to cut the volume in half, you'll multiply by 0.5, for example. And after you've done that multiplication, you'll then write that new sample to the output file, so that the updated sample with the modified volume ends up being written to the output file for each of the samples of audio in that entire file. As you go about working on this lab, a couple of techniques will be helpful. One is taking advantage of the various different types that C gives you for dealing with data of different sizes. uint8t, for example, is a type that stores unsigned integers that are 8 bits or 1 byte large. And this is useful anytime you want to
What does it mean by signed or unsigned? Integer signed or integers. Negative, 0, or positive, and an unsigned integer, only 0 or positive. Oh, so literally, like, this would be an unsigned or a signed integer, but technically speaking, I guess that would also be assigned. No, because typically they're signed. A signed integer only has a sign if it's negative, just reverting to all integers. Unsigned means, in human terms, that it must be anything that isn't negative, which is everything that is positive, and 0. Okay. So
Represent just a generic byte of data. For example, if you're trying to read in a header that has 44 bytes of data, you might use an array of 44 of these unsigned integers of 8-bit size as uint8t's inside of an array to store your header. Meanwhile, int16t is a type that stores signed integers, meaning they could be positive or 0 or negative, of 16 bits or 2 bytes each. And ultimately, this is a great choice of type for representing your samples, because we know that each sample is 2 bytes large, and int16t is the perfect size for representing this kind of information. Next, you're also going to want to deal with reading and writing files. And for that, these two functions will likely prove helpful, fread and fwrite. Fread will read a certain number of bytes from some file into memory inside of your computer, and likewise, fwrite can write data from your computer's memory to a particular.
Oh, okay, so we need to store the current, okay, so we need to read the file and store the number of bytes in that file. So that would just read the entire thing, start to finish, no specific term. And then, after that, we will have to read and increment over every single set of samples, or every 16 bytes. So our actual read and write function, we will read the file initially, get our initial variables to then write over that file, well, to the new file. Okay.
Particular file. And you'll likely want to look to the documentation for each of these functions, fread and fwrite, to get an understanding for what arguments they take in what order, and how you might use these functions to read from the input file and then write your updated data to your output file. Now, let's take a look at the distribution code that we give to you as part of this lab. You'll notice that one of the first things we give you is a constant integer called header size equal to 44. You can use this variable anytime you need to reference the number of bytes inside of the header of a WAV file as this constant integer called header size. Inside of the main function, we've already done some work for you, first checking the number of command line arguments to ensure that when the user is running this program, they're providing an input file, an output file, as well as some factor by which to change the volume of the input file. We then open the input file, checking to make sure that the input file was able to be opened correctly. We then open the output file using the W mode, W for writing that file, in order to make sure that we can open the file that we're going to be writing to correctly. And then we compute the factor, converting that factor to a floating point number, like 2.0 for doubling the volume, or 0.5 for cutting the volume in half. Here then are your to-dos. The first thing you'll want to do is to copy the header from the input file to the output file. Recall that you know that header is always going to be 44 bytes, so you'll likely want to use fread to read 44 bytes from your file, and then fwrite to write 44 new bytes to the output file. Then you'll want to go through each of the samples, likely using some kind of loop to loop through the input file until you get to the end of the file, and for each of those 2-byte samples, to read it into memory, update the volume, and then write that updated sample to the output file as well. You'll notice that we provide you with a sample input file, input.wav, which you can listen to as just a sample of audio, and you can run your volume program on this file, passing in a factor of 2.0 to double the volume, or some other factor to change the volume by a different amount, and then you should be able to listen to that new output file and detect that it does in fact have the same audio, just with a different volume. After you've done all of those steps, you should then have a program that can take any WAV file and change the volume by a particular factor. My name is Brian, and this was Volume.
Thank you, Brian. Okay. So let's watch
You might have
this down
solved
here.
the volume problem. In this problem, your task was to take an audio file and modify its volume by a particular factor, increasing or decreasing the volume of the audio file. So let's now take a look at the solution inside of volume.c. We gave you some of the initial code inside of the main function already, but the first thing you needed to do was to deal with the header, the sample byte, that header to the output file. And how many bytes are we going to write? Well, we're going to write header.
Oh, yeah. Whoops. Don't want to see that. Okay. All right. So I need to first read. Read. Okay, size underscore t, freed, void, dr, pointer, size t, in memory, file, time, stream. Think of void as representing the address of the first byte of any type of data. Think of size underscore t as a long. So size t, so 44 freed, void size. Oh, int. So we need to know a long, right? Because, yeah. As we make delete that, yeah, because we can always remake it. Okay. Yep, I was hoping that I would have a way to listen to it before I got to do anything. Okay, so we need to copy the header file. So, long, no, no long, we'll just do size underscore t, like, f is equal to fread times, and how does this one, void, the pointer, size, which is the size in bytes of the type of data to read. Oh, this doesn't look right. I think that needs to go. Oh, okay. So expect expression void. Closed it. Maybe it's because expected expression. I guess it wanted that, like that, right? Think of void as representing the address of the first byte of any type of data. Constant pointer. Oh, we want like an pattern. Void size. Still. Read 2 bytes at a time, right? No. We want all 44. No, because that just means 44, 44. Let's leave this as 1. It compiles. What if I take away void? How does that syntax work? Header size to match this. Man, I really want to watch his solution video. Maybe take just a little peek. He has just header. Um, guess that makes.
Let's take a look at how you might have solved the volume problem. In this problem, your task was to take an audio file and modify its volume by a particular factor, increasing or decreasing the volume of the audio file. So let's now take a look at the solution inside of volume.c. We gave you some of the initial code inside of the main function already, but the first thing you needed to do was to deal with the header, to be able to read the header from the input file and to write that header to the output file. The first thing you might have needed to do was to create some place in your computer's memory into which to read that header. And so the first thing we have here is the declaration of an array called header. Its type is uint18.
Header at header size. Okay, so that's why he has that header there. So, okay. So we want to declare uint 8 underscore t equal to header bracket header. So we want to, 1, write, read, and temporarily store the binary into header array. Okay, we're gonna do 44 times 1 because we're reading all 44 of the header size. Header size there doesn't make much because then story.
A type for unsigned 8-bit integers, just representing bytes. And
Oh,
how many
unsigned
bytes do we want in the
integers,
header?
8,
Well, we want
44.
header size bytes. Recall that header size is a constant integer, just equal to 44. That's the number of bytes in the header of a WAV file. So we could have written header 44 here, but it's slightly better designed to take advantage of this constant rather than reuse the number over and over.
Okay, so we're going to read and then write. Okay, so read directly to input, so we don't need this at all. Because you can't read and write in the same function. Right? So, expected identifier. Maybe all at once is like a space there, right? No. Expected identifier. Oh, there is no equal sign. Because you don't need it whenever you're declaring. Okay, right, yeah, because you don't need that whenever you're declaring integers. Or whatever frickin' data type you got. Alright. Okay, so now that will not compile because man this so we didn't make volume expected closing bracket at header size 1 to match header. So but he has there's a colon there. And that something that I overlooked here. No, because it does only have 3 colons. 1, 2, 1, 2, 3. Not one there. But what if I scroll down here? One, two, three, 4. Nope, that's printf. Function size df read 1, 2, 3. 1, 2. So header. Okay, so we are writing fread header size colon 1. Now that remember reference type file aka struct input output file is a pointer. Did you mean to use Problem but different.
By just saying header size. So we now
uint8 underscore t header size closing semicolon, which, right, we have that. Read header size, one input. Maybe it's because, look at the file. We only have an input.wav, so that's an extracted away. I'm gonna read. Oh, it's defining a temporary file input, making and assigning. Okay, so now that compiles. So if we do /volume, oh, let's just say print. No. So that compiles. So we've read it. Now we need to do the same thing but write. So we know that we are reading the header of the file, which is now overriding our header array. That is, we are reading a total of 44 bytes, so header size, okay, and then very cryptically, comma 1, and this is going to write to an output file, and okay, so copy header from input file to output file. So really, okay, so for this down here, alright, so for here we want to, something tells me we want to do a for loop because we want to sort of, we want to iterate over all of this binary data. And as we iterate over each sample, so we are going to need sample is equal to header bracket, no, not curly brackets, but brackets header 2, because 2 bytes per sample. This is an int, and we want to declare that. Okay, so now, oh no, we want to declare this inside of our for loop. So for int I is equal to 0. Let's forget our braces. So nope, int I is equal to int I 0. I is greater than the header size, because we don't need to read and write the header. That's already been done. So then I plus plus. Plus? No. Plus plus. I don't know where I got plus 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 from. I don't even think you can do that. Can you do that? Alright. And then we'll put this up here. Format for prettiness. UI plus plus plus. Oh. Plus plus I will increment the value of I, then return the incremented value. whereas I will hold. So plus plus I is dynamic. Where I plus plus will increment and hold its value. Okay. No, I'm wrong. Plus plus I will return the number of times it's incremented. So in this case, if I is 1, j is I plus plus, I is 2, and j is 2 as well because it incremented twice. But I plus plus simply the value of I. Okay, that's good to know. Sometimes it might be important to look at how many times you've incremented over something or through something. Okay, so anyway, int sample header brackets 2. Ooh. I think I want to do, I actually wanted this to be declared before because I wanted to use it for the increment. Oh. Instead of the header size, I is less than sample. I plus plus. Right? Yes. Okay. Ooh, this is a long, I believe, because 2 bytes, 16 bits. Okay. It's good to know and remember. Okay, so freed sample. So we read our sample. Let's make sure this compiles. Oh. I don't have this as right. And f close input, f close output. So actually, I think I can get rid of this. I don't even need that. And this, I had it right the first time. I is greater than the header size, because we don't want to read the header. We've already done that. So now we do want to initialize long. We'll just call this sample. long sample is equal to so that way we know or I guess we could do header size +1, but the sample is everything after the header. So yes, let's do it that way. Let's just do header size plus again +1. Oh wait, we need to read the f right. Because it's going to be different. So f right sample size sample. We want to do 2 at a time.
Have this
A buffer entity buffer int 16t buffer while. So they use a while loop. So while you're reading, oh man, yeah, I guess it's not. I guess a for loop doesn't make sense because you're not necessarily iterating over number of files. It's just dealing with one. So while one is open, you want to read it, and then inside of that have a for loop to go through all of the sample and rewrite the data. Alright, so we're going to delete this because, well, we know it's not going to work.
buffer, as we might call it, to represent the header. And now we need to read that buffer from the input file. And so here we're reading header size bytes from the input file, and we're going to go ahead and read it into the header variable that we've created here. And after we've read it into memory, then we can write that same data to the output file, calling the fwrite function and then writing the contents of that header to the output file. And how many bytes are we going to write? Well, we're going to write header size bytes. Those lines are going to have the effect of reading 44 bytes from the input file and then copying them into the first 44 bytes of the output file. Next, after the header of an input file, is going to come all of the bytes of data, the sample bytes that are contained within the audio file as well. And for each of those 2-byte samples, we want to read that sample into memory, modify it to adjust its volume, and then write it to the updated file. So here, we're going to start by creating another buffer. This time, the buffer doesn't need to store 44 bytes of data. It just needs to store enough data for a 2-byte sample. And for that, we can use the int 16.
So what I was trying to do with this, I just don't need. So while, we need a while loop.
T type for a type that stores an integer with 16 bits. And now,
Integer types. Okay, so that is int 16 underscore t is a type of integer. And it's a signed integer because it can be frickin' anything. Okay.
we're going to repeat this inside of a loop. We're going to use the fread function to read from the input file into the buffer, passing in the address of the buffer so that fread knows where to put the memory that it's reading. And we're going to read one sample of 16 bits, in other words, 2 bytes. And because this is in a loop, the effect this loop is going to have is it's going to repeatedly read a sample, one sample after another, until we reach the end of the file. fread returns to us the number of blocks of data it was able to read successfully. And so once it's no longer able to read any more data from the file, fread will return 0. And at that point, while is going to treat that as false and will exit the loop. So now we've read the sample into memory as this variable buffer. And now we need to update the buffer by multiplying it by factor. If factor is 2, that has the effect of doubling the volume.
Is factor something that we have already declared? Yeah, we have. Huh. Okay, so... Okay. Nope, it's not an unsigned integer because it can be anything plus or minus 0 underscore t. Nope, we already know it's an int. It's an int of 16 underscore t type. This is the buffer. Sorry. Hold on. How did he declare it? Oh, that's it. Just int 16 buffer semicolon because it's just, hey, this exists now. And it is 2 bytes or 16 bits. So while fread at buffer size of at buffer no, not buffer, int 16 because, well, a bit more exact. I'll say we don't need one of those. We do. Like I have one too many. 1, 2. Oh. We're not done, that's why. Right. Temporarily in buffer 16 bits. This is going to be our input. And then, okay, so while buffer, he has buffer equals to buffer to up, no.
If applying it by factor. If factor is 2, that has the effect of doubling the volume. Read the sample into memory as this variable.
We're going to update the buffer as the factor. What? That's kind of weird. How does it read? The multiplication assignment operator multiplies a variable by the value of the right operand and assigns the result to the variable. Okay, so it is updating it, but multiplied by factor, which we know is 2, well, whatever the user inputs. Not 2. Buffers 2. Bytes, while factor is whatever the user inputs. So now that the buffer, everything that's stored inside the buffer is multiplied by the factor, we can then fwrite into our at buffer size of int 16t closing brackets input. No, output. So that's pretty simple. While, yeah, that makes all the difference. The while loop reads our file of input, which is input.wav, but it's input.wav is a little too explicit. It doesn't help that. But it reads our file, updates our buffer, or our temporary container of our memory, and then writes from that temporary container to our output file at a size of 16 bits per read, because it's only reading 2 bytes at a time. It will go through and continue doing this while the file is still being read, until fread, per the manual pages, returns 0 and the while loop stops. So
buffer. And now we need to update the buffer by multiplying it by factor. If factor is 2, that has the effect of.
So now, if we do make volume, too few arguments to function call, expected 4, have 3. Oh, I think I messed up the well, fread 43 to 47. Oh. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16, 17, 18, 19, 20, 21. 7. So probably help if I could see the how to get dots in VS Code. Ah, there we go. Okay. So now we don't have to count all of these. So buffer factor f right of buffer size. On the input side, oh, I forgot the 1. There's not a 1 there. What is the 1 for? Like, number of those types to write at once. So 1. So n mb. And mb. Okay. So 1 of basically 1 times 2 bytes because, okay, and that is why we get the the third semicolon dividing it into 4 elements of the function, because these are 2 different values, 2 different elements. So the size of this number, and this is how many times it's read, kinda. Okay, so now it should not, size of, get rid of some of these, there we go. So dot slash volume input dot wav output dot wav 0.5 to 0.5 for fun. It worked. Did that give us an updated? It did. Okay. So now let's run our check 50. See what it has to say. Oh, I control paste. Alright. Open this up because last time I didn't get all my points because I was only reading from like here down. And I thought everything was good, but I wasn't. So thank you, runoff. Hour and 14 minutes later of lab 4 memory complete beginner. Okay, exists, compiles, reduces audio volume factor 0.5 correctly, reduces volume, increases audio. So, okay, so I guess in a nutshell, I can work my computer. Just do that, submit. While that's submitting, so we learn how to use the fread and write function. We learned how to change the size of an integer. Not change size, but the type of integers that we can manipulate. Yes. Plagiarism, FTW. So we used how to use fread, fwrite, different types of integers, and mainly that's it. why this takes 3 commas, dividing it into 4 elements. Pointers, pointer at the buffer. Buffer times factor, I mean that's it. How to manipulate pieces of memory, or more abstractly, how to manipulate files. Okay, well, that's that.